Hello everybody, my name's Chris Ward and I'm one of the product managers for the control product business for Siemens, and in this worked example I want to demonstrate some of the functionality with the SIMOCODE Pro, and the function that I want to discuss today is the undervoltage release and undervoltage monitor capabilities. So I'm going to already assume that you have a base project, whether that's a DOL or a reverser, whatever the case may be. If you don't have that, you can refer back to one of my previous videos to show you how to build that base project up. So why would we use this undervoltage function? So typically when you're looking at undervoltage, if you do have a dip in voltage, it causes a higher current for a constant power supply. So the idea is that the higher the current, the more heat it creates, and that could damage the motor. So the idea is if you're utilizing some form of monitoring capabilities on the undervoltage conditions, you'll prevent the motor from any damage created from any undervoltage that the system might see. Another feature would be that the device also monitors hysteresis discrepancies in this feature as well. So you could utilize that for an underperforming motor. So if you have a discrepancy in hysteresis, you might have a low efficiency motor. You'll have low torque and you'll have a low power factor. All of those conditions are undesirable in a motor application. So I'm going to jump in now and show you the feature and how to access it. So firstly, we'll just minimize this window down. We can then go into the SIMOCODE station, drop that arrow down, go into parameters. We can close this window down now. And if we go into machine monitoring capabilities, you can see here voltage. Let's have a little look at the voltage menu here. We can also bring that to a close to gain more access on the function, so we can gain more visibility of what it is we're looking at. As you can see here, there's only one limit for a voltage, and that's this lower limit. We also have this hysteresis function, which I briefly mentioned before. So how do we program this undervoltage monitoring capabilities? Well, here you can decide on what trip level you want that voltage to trip out at, and that can range from anywhere. If you hover over the menu, it'll tell you. So if you go hover over it, trip level, as you can see here, 0 to 2040 volts for the line voltage. So we might want that to be 110 volts. So this is the actual trip level response. So if we was to go down to 110 volts, we would want the device to acknowledge that fact and decide how we react to that. So here underneath you've got the response to the trip level. So you've got your trip level and then you've got the response to the trip level. So response to the trip level can be anything from a signal to a trip. Normally under these kind of conditions, you would want the device to trip out, specifically if it was a particularly low threshold that you've set the device to. So we'll assign trip on that. As you can see here, you've got trip level, active status. There's three different options here. You've got always on except with TPF on, and if motor is running, except with TPF run. So what's TPF? TPF is a cold function which allows you to test and simulate the SIMOCODE station without a load effectively. So it allows you to do a cold start. Now, 9 times out of 10, you can, if you're not using the TPF function, you can just have that as always on. And then if you say, for example, you was using the TPF function, you could perhaps have it as always on except if you've got the TPF function active. Typically though, I would generally say that you could always have that as always on, providing that you're not using that TPF function, because you'd only use TPF normally when you're when you're doing a test of the station without a load. You can decide on a trip delay as well. So if you've got fluctuations in voltages, you might want to put a delay on that to eradicate any nuisance tripping based on small fluctuations in the voltage. Similar to the other functions, you've got a warning level as well. So you might want the warning level to be, it'll have to be slightly higher than the trip level. You might want that to be 140, say. And then once you've done that, again, you decide on how you want that to react here. So you can either have a signal or a warning. I mean, because you've got a trip at the maximum level, you'd probably want just a warning on the HMI screen displaying that the device is going, dipping towards the ultimate threshold here, which would also tip off an engineer that some maintenance might be needed on the motor and the application might need to be looked at. Again, warning level active status, we can have that as always on, and you can also have a delay on the warning function too. In terms of the hysteresis, any discrepancies between the power factor, you might want that to be anything from between 0 and 15%. So I mean, typically it automatically assumes 5% here, but if you want to give it a bit more leeway, you can change that to say 10%. Once you've done that, then you can download that into the SIMOCODE station, and you can test it for the general operability to ensure that the device is working as it should. But with those parameters and assignments, it's always good once you've designed a function to be able to go back through it and simulate it in the application rig to ensure that the device is operating as you want it to before you put it out into the field. So I hope you found that video useful, and if anybody has any questions, please feel free to leave them in the comments box, and please stay tuned for more videos. Thanks very much.